we talked about matrices and the fact of it's just another way to represent systems of equations. You have an augmented matrix, which has all the coefficients on the left-hand side. On the right-hand side has the answers of the constants. You should be able to write matrices and equations interchangeably. So if I give you an equation, you should be able to write the matrix and vice versa. You need to know how to write the dimensions of a matrix. It's row by column. All right. We're going to talk about adding them and multiplying them and finding inverses of that and all that in the next few days. But right now, we're going to do something, and I'm not sure if we're going to have a question on your test that you have to answer exactly like this, but you need to understand how to think in terms of a matrix. We're going to do something called elementary row operations. And all it means is you can either interchange rows, you can move one row up to the top, one to the bottom. You can multiply one row by something else. You can add rows together, but we're going to do something to create a pattern so things cancel out. It's very similar to elimination when you're eliminating x's or y's. We're just using it with coefficients. What you want when you're done with all of your elementary row operations is you want your matrix to look like this picture here. Do you see how there's ones? I'm going to say there's ones on the diagonal and then zeros underneath. The first thing you should concentrate on is getting this number to be a positive 1, which that would be a positive 1x value. Then you want to concentrate on getting the two numbers underneath the positive 1 in the x column to be zeros. Then you move over, and as you're very methodical in following the steps of trying to get the first column to say 1, 0, 0, it kind of works itself out to where this pattern will be created. So on your web assigned tonight, you guys have questions where it'll give you the matrix and it'll say multiply row 1 by 1/2, which just means divide by 2. It'll say add row 3 to row 2, something like that. You're just getting in the practice of doing that. We're going to actually solve an entire system of equations using this elementary row operations. With the stuff that we do you guys see here how it says they added row 1 to row 2? Here we multiplied -2 to row 1 and then added it to row 3. We are not going to do any where you have to multiply by a fraction. So if you get something, guys, where you have fractions, then you did something wrong. So just make sure you are paying attention, you see that. All right, so we're going to do these two together. Together as a group, we're going to do them. And you guys should probably rewatch this video before your test just to make sure you understand what's going on here. But last week, we used Gaussian elimination with back substitution. Meaning you wanted your equations in row echelon form, meaning the first one had x, y, and a z. The second one had a y and a z. The third one said z equals, right? And then we used back substitution. You were given equations like this, and we had to manipulate to where we combined the first and the second, got rid of the x's. Combined the first and the third, got rid of the x's. Then combined the two extras and got rid of the y's, that sort of a thing. We're going to be doing the exact same thing here, but with absolutely no letters. All right, so the first thing you want to do is you want to set up your matrix. So let's just set up our matrix with what we have here. What does my first row look like? -1, 1, -1, and what? -14. Okay, good. What's the second row look like? 2, -1, 1, 21. And the third row is 3, 2, 1, 19. Now, this can get really messy and really, really confusing in a hurry. So I suggest you guys focus on one row at a time. All right, remember, we want our diagonals. We want our matrix to say 1, 1, 1, and then zeros underneath like this. That's our goal, and I'll show you why in a second. So the first thing I'm going to do is I'm going to focus right here. What do I have to do to this row so that that is a positive 1? What would I have to do? Okay, so I'm going to write out here, I'm going to say -1 times row 1. Now, I'm not doing anything else to any other row. Leave it alone. So I'm going to rewrite the second row to -1, 1, and 21. 3, 2, 1, and 19. I didn't do anything to those two rows. But I am going to multiply the first row by -1 to create my first. So -1 times -1 is 1. -1 times 1, -1. -1 times -1, 1. -1 times -14, positive 14, correct? You guys with me? All right, so we're just going to continue now. I have a positive 1 right here. So underneath my positive 1 in my pattern, what do I want that 2 to become? I want this to be a 0. So what am I going to have to do? That's what I'm going to focus on right now. Once you guys get that first row how you want it, leave it alone. You're just going to rewrite it 25 times. 1, -1, 1, 14. We're not touching it. We're not fixing that. We're just fixing that second row. I'm going to leave the bottom one, 3, 2, 1, and 19. So what can I do? What can I multiply one of the rows? You guys don't always have to do the same thing. Everybody's not going to do the same thing. That's okay. But what's the easiest thing to do? What could I multiply one of the rows by so when I combined two of them, that 2 would cancel out? Okay, I agree. What kind of 2? If I multiply the first row by -2 and I add it to the second row, then that 2 will cancel out. So -2 times 1, -2. -2 times -1 is 2. -2 times 1 is -2. -2 times 14 is -28. Then the second row is 2, -1, 1, and 21. So when we combine these, what's -2 and a positive 2? 0. What's 2 minus 1? 1. What's -2 plus 1? And -28 and 21? -7. So now I've created this row, and it's 0, 1, -1, -7. All right, so I have 1 in the first spot where it needs to be. Then I have a 0, 1. Okay, perfect. God bless you. So now I'm going to work on this 3. I need that 3 to cancel out. I need that 3 to go away. So my first row is fine. I'm leaving it. 1, -1, 1, and 14. My second row is good. I'm leaving it. I have to fix the 3. So what am I going to multiply a row by so that when I combine them, the 3's cancel out? Where? To the top one? Okay. I'm going to say -3 to the first row, and I'm going to add it to the third row. So -3 times 1 is -3. -3 and -1 is 3. -3 and 1, -3. -3 and 14, -42. And then my third row is 3, 2, 1, 19. Okay, so -3, positive 3? 0. 3 plus 2 is -3 and 1 is, and -42 and 19? -23. Okay, so I have 0, 5, -2, -23. Good. All right, so let's take an inventory here. This needs to be positive 1. We're good. This needs to be 0. This needs to be 1. This needs to be 0. Okay, so what do we need to work on? The 5. Everything in the first row, perfectly fine. Leave it alone. Everything in the second row, perfectly fine. Do what? Leave it alone. So 1, -1, 1, 14. 0, 1, -1, -7. All right, what do I need to do? What row? You want to do the second row, -5, God bless you, times row 2 plus row 3? Okay. So if I put a -5 out here, I have 0, -5, positive 5, and 35. Agreed? Change color so you can see better. Then I have 0, 5, -2, and -23. What's 0 and 0? 0. What's -5, positive 5? 0. What's 5 minus 2?
3.
And 35 minus 23? What is it? 12. Okay, so I have 0, 0, 3, and 12. All right, so I'm good with the first row. I'm good with the second row. I'm really close with that third row, but I need that 3 to become a 1. Divide what by 3?
The last row.
Yep. Can I divide that whole last row by 3?
Yeah.
That's generally your last step. When you guys get really close, it's like, oh, let me see if I can do anything with that third row. If I divide the whole third row by 3, I'm left with, first row is still fine from the first step. This is super easy to make mistakes here. 0, 1, negative 7. 0 divided by 3 is 0. 0 divided by 3 is 0. 3 divided by 3 is 1. And 12 divided by 3 is 4. So now you guys are like, why did we do this? Right? Write your system of equations from what I have left over. What's my first row say? X minus y plus z equals 14. What's my second row say? Y minus z equals negative 7. And what does the third row say? Can I now use back substitution and just plug in? Yep. So I take this and I put it here. And I have y minus 4 equals negative 7. So y equals what? Negative 3. Then I take that and I plug both of them into the top. So x minus a negative 3 plus 4 equals 14. Minus a negative is just same as plus, right? So x plus 7 equals 14. What's x equal? Negative 7? Positive 7. And then what's my ordered triple?
7,
Perfect. Now, a lot of you are looking at that and saying, why? Why? There are people that, Mateo just sat here and goes, this is easy. Like, there are people that just see numbers like this better than others. People that like Sudoku puzzles or that good at something like that. Like, this is just an alternate way of solving a system of linear multivariable equations. If the question says solve using matrix row elementary operations, you have to do that. If it just says solve, then you can do it like we did last week, or you can do it like this. But it's just showing you an alternate way to solve these problems. You don't need the X's and the Y's and the Z's. You'll put them back in at the end. Let's do another one and then we'll be done. All right, what's my first step? Write the augmented matrix. Let's write it out. So I have 1, negative 2, 3, and 9, correct? Negative 1, 3, 1, negative 2, 2, negative 5, 5, 17. Do not make things harder than they need to be. Do I need to do anything to the first row? No. Look, I already have a positive 1 there. So now, from now until we're done with this problem, we just keep rewriting that row the exact same way. Row 1 does not change. It's 1, negative 2, 3, and 9. Are we doing anything to the third row right now? No. So I'm just going to rewrite it. We're not going to do anything to it. Don't even worry about it. I have to do something with rows so that this cancels out. Don't make this harder than you need to. What would you have to do? You could multiply by negative 1 and then recombine. But what really and truly, what could we just do? Can I just add row 1 and row 2? 1, negative 2, 3, and 9. Negative 1, 3, 1, negative 2. What happens with 1 and negative 1?
You cancel.
Cancels, becomes a 0. What's negative 2 and 3?
1.
What's 3 and 1?
4.
And what's 9 minus 2?
7.
So I have 0, 1, 4, 7. So my first row with 1 there, perfectly fine. My second row with a 0 and a 1, perfectly fine. So let's focus here on the 2. Okay, again, our first row is fine, and so is the second row. So just rewrite them. 1, negative 2, 3, and 9. 0, 1, 4, 7. Now, I want net 2 to cancel out. So what should I multiply what row by?
1, the first row by the negative 2.
Okay, first row by -2. I agree. First row by -2. So I'm going to say -2 times row 1, and I'm going to add it to row 3. So I have -2, 4, -6, -18. And then row 3 is 2, -5, 5, 17. What happens with -2, +2?
Cancel.
Cancels. What's 4 minus 5?
Negative.
What's -6 plus 5?
Negative.
What's -18 plus 17? -1. Okay, so 0, -1, -1, -1. All right, so let's reevaluate. First row is still good. Second row is still good. Third row. This is okay here. We got to focus on this. So what can we do? Okay, you can add the second and the third. We don't really have to do anything else. First, again, first row is still fine. It's 1, -2, 3, and 9. Second row is still fine. 0, 1, 4, and 7. So we're going to add row 2 to row 3. Okay. So 0, 1, 4, 7. 0, -1, -1, -1. What happens to my zeros? 0. What happens with 1 and -1?
0.
0. What's 4 minus 1?
3.
And 7 minus 1?
6.
0, 0, 3, 6. What's the last thing I need to do? Row 3 divided by 3. So I'm left with 1, -2, 3, and 9. 0, 1, 4, 7. 0, 0, 1, 2. So how would I write my system of equations? What's the first one say?
X
Minus,
2y
yep,
plus 3z
equals, perfect. Then what?
y plus 4z equals 7.
Yep. And then z equals 2. Question?
Why didn't you just divide by 3? You can have like a 3 there.
You want it to be a positive 1z.
Oh, it's
You could write 3z equals 6, but
Right.
to be complete, to match your pattern of ones on the diagonal, that's why you. So now we use our back substitution. Good question. So we take z and plug it right there. So y plus 4 times 2 equals 7. Y plus 8 equals 7. So y equals -1. And take that, plug it into the top. So x minus 2 times -1 plus 3 times 2 equals 9. This becomes x plus 2 plus 6 equals 9. X plus 8 equals 9. So x equals 1. What's your ordered triple? 1, -1, 2. And then what can we do with those three numbers? Plug it back in.